Hello dear students, today we are going to solve chemistry paper unit 3. In this, the very first question is, tests were carried out on some pairs of compounds. A. First, bromine water was added to separate solution of sodium chloride and sodium iodide. State one different observation for each reaction. So when bromine reacted with sodium chloride, okay, so as you know, chlorine, bromine and iodine, down the group reactivity increases means chlorine is more reactive than down the group reactivity decreases. Chlorine is more reactive than bromine and bromine is more reactive than iodine. So chlorine can replace bromine and bromine can replace iodine, but iodine can't replace bromine and bromine can't replace iodine. So in case here we have chlorine and it's water, so there will be no reaction, so solution turns lighter. Okay, and when sodium iodide, bromine water reacted with sodium iodide, bromine reacts with iodine and its color become darker. Now second part, name a test which with the expected observation to confirm the presence of sodium ion in these compounds. So the test can be flame test and the observation is yellow orange. Okay, sodium ion color is yellow orange. Now B1, barium chloride solution and hydrochloric acid were added to separate aqueous solution of ammonium sulfate and ammonium nitrate. State what would be seen for each compound which would allow you to distinguish between them. So when barium chloride solution and hydrochloric acid is added to ammonium sulfate, it forms a white precipitate, and when it reacted with ammonium nitrate, there will be no reaction. B. Second part. Give a test with the expected result to confirm the presence of ammonium ion in the ammonium compound. So that to test for confirming ammonium present in a compound is add sodium hydroxide NaOH solution and warm the mixture. Then the result will be a gas will release, that is ammonia NH3 can be recognized by its smell. Its smell is pungent smell, which will turn litmus paper as blue because ammonia is only alkaline gas or it's a basic gas. Now the C part 1, acidified potassium dichromate. Oxidation number 6. Solution was added to 2 test tubes, each containing a different alcohols. The test tubes were placed in a warm water bath. The alcohols were propane 1-ol and 2-methylpropane 2-ol. State what would be seen for each alcohols which would allow you to distinguish between them. So propane 1-ol, it's a primary alcohol and it's 2-methylpropane 2-ol. So 2-methylpropane 2-ol and it's a tertiary alcohol. So when primary alcohols reacted with acidified potassium dichromate turns to green color. That solution turns to green color. And when the same this a tertiary alcohol reacted with a same acidified potassium dichromate, it becomes no color changes or remains orange. Means here in first case, primary case, the orange color turns to green, but when we use tertiary alcohol, there is no color change and orange remains orange. Now the second part gives a chemical test with the expected observation to confirm the presence of hydroxy group. So the test is add glycyl acetic acid and concentrated H2SO4 and warm it. Okay, means alcohol plus acetic acid, glycyl acetic acid in the presence of concentrated H2SO4 and warm it. A ester will be formed. And ester has a fruity smell, so the observation will be fruity smell and of ester. Now the D part is acidified potassium manganate 7 solution was added to separate test tubes containing samples of hexane and hexene. The test tubes were shaken gently. State what would be seen for each compounds which would allow you to distinguish between them. So when acidified potassium manganate react with hexane, there is no reaction and color remains purple. But when the same acidified potassium manganate reacted with hexene, they it becomes colorless. The purple becomes colorless. Now, the second question, a class of students carried out experiment to determine the enthalpy change for the reaction of magnesium metal with hydrochloric acid. The following methods was used. Step 1, a 1 meter long length of magnesium ribbon was cleaned using sandpaper, weighted and cut into 10 centimeters length. Step 2, 50 centimeter cube of dilute hydrochloric acid. An excess was placed into a polystyrene cup and the temperature measured. Step 3, a 10 centimeter length of magnesium ribbon was added to the hydrochloric acid and the solution was stirred gently and mixture and the maximum temperature recorded. The reaction would be this. So the results, measurements, mass of 1 meter of magnesium ribbon in grams is 0.86 gram. Initial temperature of hydrochloric acid before addition of magnesium ribbon is 21.4 degree and final temperature of solution is 29.2 degree. So the first A question is calculate the number of moles of magnesium in this much length of ribbons. So if you have 10 centimeter length of ribbons of magnesium, so 1 meter mass for 1 meter length is 0.86. So for what will be the mass of this much magnesium? So you can divide it this by 10 or you can find it out by this formula 10 divided by 100 because of 1 meter length has 10 centimeter cube 10 centimeter, so you can use this formula and the mass will be 0.086 gram and number of moles can be find it out by the mass divided by molar mass. Okay, mass divided by molar mass, so the number of moles will be 3.54 into 10 to minus 3 moles. Okay, now the second part, calculate the enthalpy change for this reaction including a sign and units. Give your answer to appropriate number of significant figures. The data, specific heat capacity of the solution is 4.2 joules per gram per degree Celsius and the density of reaction mixture is this. So the change in temperature, the delta theta is temperature change, is final temperature minus initial temperature, so that will be 7.8 delta theta value. Now the heat, the Q value, Q is equal to ms delta theta. M is the mass, and here it is given this density of the solution, and we have taken 50 centimeter cube of dilute sulfuric acids. So therefore it will be 50, and the density is 1, so mass will be 150. Density is mass divides by volume. So for finding out the mass, multiply density into volume. So when you multiply this, so you will get 50 grams of mass, and the specific heat capacity is 4.2, and the delta theta is 7.8. So the total will be 1638 joules, 1638 joules. Now for finding the enthalpy, you have a formula delta H is equal to minus of Q upon number of moles. So delta H is equal to minus 1638 divided by 3.54 into 10 raised to minus 3, and after solving this you will get minus 462 kilojoules per mole. Now the B part 1, the maximum uncertainty each time the thermometer was read was plus minus 0.1 degrees Celsius. Calculate the percentage uncertainty in measuring the temperature change in this experiment. So it will be maximum change 0.2, okay, times 100 divided by 7.8. So the uncertainty will be 2.56%. Now part 2, suggest one way of reducing the percentage uncertainty in measuring the temperature change without changing the apparatus or just repeating the experiment. Justify your answer. The first you can do this by taking more magnesiums, or so temperature will rise more. Okay. Now C part. One student carried out the same experiment but used a glass beaker instead of polystyrene cup. State how this would affect the values of enthalpy change obtained. Justify your answer. So if a glass beaker is used instead of polystyrene cup, so because of glass is non-insulator, it will absorb some heat. So the non-insulating glass will absorb heats, and the reaction will be less exothermic. It will release less energy. So therefore the reaction will be less exothermic. Now D part. Explain why the magnesium ribbon was cleaned with sandpaper before being weighted. Because magnesium combines with oxygen present in air to form a layer of magnesium oxide on its surface. So we use sandpaper to remove the oxide layer, because MgO, magnesium oxide, has a different enthalpy. Okay. Now the third question. An experiment was carried out to determine the purity of solid sodium carbonate. The following procedure was used. 4.89 gram of impure sodium carbonate was weighted and dissolved in distilled water. The solution and washing were transferred to a 250 centimeter cube volumetric flask, and the liquid level made to the mark with distilled water and flask shaken. A peptide was used to transfer 25 centimeter cube portion of the solution to the conical flask. Each portion of the solution was then titrated with hydrochloric acid of concentration of 0.2 mole per decimeter cube. So the reaction is this: 1 mole of sodium carbonate reacts with 2 moles of hydrochloric acid to form 2 moles of NaCl and 1 mole of water liquid and 1 mole of carbon dioxide. So the indicator used was methyl orange. State the color change at the end point. So from yellow to orange. So results are number of titrations: titration 1, titration 2, titration 3 and titration 4. So burette reading was 27.55, 26.25, 28.3 and 26.15. It was final reading, and burette reading starting at start. So here it was completely empty, 000, and in second there was some liquid, in third there was some more, and in fourth there were also some. So finally the volume of HCl is how much in first condition? So it will be 27.55, but in second we will minus because it was already present there. So we will minus, so it will be 26.2, and here it will be 27.25, and in the last one it will be 26.1. okay, so now complete the table and using appropriate titration calculate the mean value. Appropriate titration, so these two are appropriate, the second and the fourth one are appropriate, so take the mean value of these two, this and this, and you will get the mean titrate is 26.15, and we will use this in further questions. Now second part, calculate the percentage purity by mass of the sodium carbonate. So this is for 25 centimeter cube of HCl. This reaction and this whole equation is for this much volume of HCl. So number of moles of HCl is concentration multiplies volume. So concentration is given to us 0.2 moles per decimeter cube, and the volume can be we got it here 26.15 centimeter cube, but we need it in decimeter cube, so we will divide by 1000. It will become decimeter cube. So you can do this and you will get the number of moles of HCl as 5.23 into 10 to minus 3 moles. And as we know, the sodium carbonate has half of the HCl mole. So if we get 2 moles, so we need only half moles of 1 mole of for this. So after calculation we get number of moles of HCl as this, so we will divide this by 2 and we will get the number of moles of sodium carbonate as 2.6 multiplies 10 to minus 3. Now the mass of sodium carbonate, as because this number of moles only present in 25 centimeter cube of solution, but we have 250. Okay, so we will multiply 10 times and in the molar mass, so you will get the original molar mass of sodium carbonate, that is 2.77 gram, and the percentage purity is theoretical mass divided by given mass. So theoretically we get 2.77 and given mass is 4.89 multiplies 100, so we will get 56.7 percentage of purity. Now question 4. Bromoethane can be prepared by reacting ethanol with a mixture of sodium bromide and concentrated sulfuric acid. So step 1, 5 centimeter cube of ethanol and 5 centimeter cube of water are added to a round bottomed flask. The flask is placed in an ice bath and 5 centimeter cube of concentrated sulfuric acid is added slowly. During this process, the flask is gently shaken. Explain why sulfuric acid must be added slowly. Because sulfuric acid reacts violently with alcohol and water to release heat. Hence, the reaction is exothermic. So, therefore, the sulfuric acid must be added slowly to prevent the mixture from boiling. Because it is exothermic, so it can boil the solution. So therefore the sulfuric acid must be added slowly to prevent the mixture from boiling. Now the step 2, 6 gram of solid potassium bromide is grounded up into a fine powder using a pestle mortar. The powder is then added to the round bottom flask containing the ethanol and concentrated sulfuric acid. The mixture is heated. State why the potassium bromide is ground up to a fine powder. Justify your answer. Because the rate of reaction increases as the surface area of potassium bromide increases. Okay, because if we increase the surface area of anything, so it can react faster, so the reaction will fast. So to increase the rate of reaction, we use potassium bromide in fine powder so that the reaction become faster. Okay, step 3, a crude bromoethane formed in step 2 is distilled off. Okay, so draw a label diagram to show the apparatus suitable for this distillation. Include a thermometer but no clap or stands. So this question we will take help of mark scheme. Okay, see, this is the diagram. You can draw here a thermometer and close till here you have a valve and water out, water in. So you can see and you can read and you can make this diagram in your answer. Okay, so we are going to do the next one. Here, state how anti-pumping granules prevent pumping in the distillation flask. So for this also you can take help from mark scheme. This promote smooth or even boiling or provide sites for bubbles to form. Sites for nucleation promote small and bubble formation. Okay, you can write one of these. You can promote small bubbles formation or you can cite for nucleation. You can write any of the So now the step 4. Distillate from step 3 is transferred to a separating funnel where it separates into an aqueous layer. A layer contains impure bromoethane. So what is here? The upper layer is aqueous layer and the lower layer is bromoethane layer. So state two physical properties of bromoethane that can be deduced from this diagram. Because the bromoethane settle down at the lower ends, so it means it is heavier liquid. So you can say bromoethane is more dense or higher density than water. And the second one, you can say, because they are forming the layers, so you can say it is immiscible with water. Okay. Describe how the aqueous layer could be removed from the separating funnel. So you can open this and open till this layer comes in the next beaker, and when it comes here you can close. So open the tap and take the bromoethane layer into another beaker and then close the tap. Now the fifth step, after removing the aqueous layer, sodium hydrogen carbonate solution is added to the impure bromoethane in a separate funnel and the two layers separates again. State why sodium hydrogen carbonate solution is added to the impure bromoethane. So the reason is to neutralize the acid or H plus ions or H3O plus ions. The step 6. The bromoethane is placed into a sample bottle and a drying agent is added. Identify by name or formula a suitable drying agent. So you can use calcium sulfate, and you can use other also silica gel like silica gel. Then you can use calcium chloride CaCl3. Okay, you can use one of these dry agents. So I have right here calcium sulfate is also a dry agent. And you can the second part is describe how the appearance of bromoethane change after drying agent has been added and the mixture allowed to stand. So after adding the dry agent, so bromoethane become less cloudy. So here we have done. So thank you for watching the video.